So if we're talking about if P then Q, the strict way of thinking about what that statement means is the following. So if P then Q means that the antecedent of a conditional statement, so the first part behind the if is the antecedent, is sufficient but not necessary for the consequent to be true. And similarly, the consequent is a necessary but not sufficient condition for the antecedent. All right. What that means basically is what you talk about when you talk about raining clouds. What you say is that as soon as you know that it's raining, I know that it's cloudy. So that means that if it's raining, that's a sufficient condition for there to be clouds. Saying that when it rains it's cloudy, or saying that the consequent is a necessary but not sufficient condition for the antecedent, means that you can't have rain without clouds, which is something basically everyone would agree with, right? Because as soon as it rains, it's cloudy, so it also means that you can't have rain without clouds. Or another way of saying is that if it's not cloudy, then it's not raining. What I'm trying to point out to you is that what the logical relationship is implied by the statement if P then Q. So P, or the antecedent, is a sufficient but not necessary condition for Q, and Q is a necessary but not sufficient condition for P. So that's basically their status differs, right? And that creates an inequality, and that creates a confusion when reasoning about if P then Q. So if you apply that to a random example, if something dances, it's a human being. That means that dancing, in this case, something dancing, is a sufficient condition for something being human. So if you see, as soon as you see something dancing, you can conclude it's a human being. And being a human being is necessary for dancing. So if you know something is not a human being, you know that it can't be dancing. It's worthwhile to remember this stuff. So you have two options now. You can either try and memorize the different forms of logically valid arguments, right? So the modus ponens, modus tollens, and try to remember which the valid ones are and which the invalid ones are, and trying to recognize that in the different examples that we use. If you're not satisfied with just memorizing that stuff and recognizing it in the examples, you could also opt for doing a somewhat more deeper dive and properly understanding what if P then Q actually means. And that's what we just talked about. If P then Q means that P is a sufficient but not necessary condition for Q, and it means that Q is a necessary but not sufficient condition for P. If you properly understand that logical relationship, it becomes easier for you to assess logical equivalence. So if I'm saying to you, if it's raining, then it's cloudy, essentially means, in logical terms, means the same as saying it's cloudy if it is raining. And you can see why it means the same, right? Because we just said that if P then Q means that it describes a logical relationship. And the first thing you should bear in mind when trying to judge whether something is logically equivalent, by which we mean, sure, this sentence is different from the first sentence, but they describe the same logical relationship. And if that's the case, then we call that thing logically equivalent. We can see that this is logically equivalent, or it's easier to see that if you remember that it's about the logical relationships and not about the place of the words in the actual sentence used. So even though the place of the words in the sentence is different in the second sentence compared to the first one, they still describe the same logical relationship. So the if it's raining part is in the back of the sentence, but the logical relationship expressed is still the same as in the first example. All right. Is raining sorry, yeah, go ahead.
Would you write that then as Q if P? Or would you just not write that?
Well, you could write it. So you could say if it's raining, then it's cloudy. Useful bypass is just to put everything behind if in a bracket and call that P, and everything behind then put it in a package or between brackets and call that Q. And if you then look at the next sentence, you see that it is cloudy, Q, if P is what it says, and that's what you meant, right? So yeah, that would be the summary, and you see that the logical relationship is still the same, right? Because the P part is still behind the if part, and the consequence of that is still that it's cloudy. I hope that answers your question. All right.
Yeah.
Okay. If we're saying it's raining only if it's cloudy, that seems to describe something else, but it's still expressing the same logical relationship. That's what it means to say that it being cloudy is necessary for it to be raining, right? We know that without clouds there cannot be rain. Another way of saying that same stuff is saying that it is raining only if it is cloudy. It's a different sentence, but it expresses the same logical relationship. The next one is a bit more difficult. So saying that either it is cloudy or it's not raining still expresses the same stuff, but it's a very weird way of talking, and that's what throws most people off. So if I'm asking you to judge whether this one is logically equivalent or not, then well, there's two ways of going about this. Again, you could recognize different argumentation forms or different ways of describing if P then Q. And if you know that if P then Q is logically equivalent to Q or not P, then you learn to recognize that this statement is logically equivalent to the first one. So that's the first way to go about this. Use this list of examples and study the relevant pages in the book in which this is described in more detail. And you can recognize those different forms, different ways of expressing the same logical forms. So those logically equivalent forms to P, if P, then Q. And one of those is indeed either Q or not P. Which is a very weird, so the easiest way to get this is to basically see that saying either Q or not P is basically the same as saying, so what we're saying here, either Q or not P, so if this first part is false, so it is not cloudy, the second part has to be true, so it must not be raining, right? Which is again the same as saying without clouds there can be rain, or is the same as saying that clouds are necessary for there to be rain, which is to say as saying if it's raining then it's cloudy. All right. We're not going to cover all these in detail. I've talked about the most important part, that is that you should be train yourself to focus on the logical relationship and learn to recognize that. If you think I'm confused by those logical relationship, the backup option is to just learn the different examples by heart, different forms of logical arguments and different ways of logically, in a logical equivalent way, expressing the statement if P then Q. You can learn it by heart as well. There's about six alternatives described here with a different example, and in the book they're covered with the terms if it's raining then it's cloudy, and you can learn those by heart and learn to recognize them, and you're good as well. What I would propose I do, because some of you indeed indicated that you were somewhat confused up to now, so I think a good option is that I will explain why all these 6 statements are logically equivalent to the first statement in a separate video. I'll try to make it a short video, but in that video I will explain to you why those are logically equivalent and give you different tools to try and see whether it makes more sense using those tools to see that those are indeed expressing the same logical relationship. That video, of course, is optional, so I'm offering different tools. If you thought what I was saying here with this slide made all the sense you'd like, right? So that's perfectly logical to you, and you studied the relevant passages in the book and that made sense to you as well, then there's no need to view that extra video. But for those of you who are still confused at that point, I think it might help to have that video with those extra tips and extra tricks for working out whether something is logically equivalent or not.